In this video, we are going to look at the problems in the 4-2 slides. Starting with this problem, 555 subjects are given a drug test and results are shown in this table below. If one subject is randomly selected, what is the probability that the subject had a positive test result or uses drugs? So I have copied that table over here. We have 45 people use drugs and have a positive test result. 5 use drugs and have a negative test result, for a total of 50. 45 used and 25 use drugs and have do not use drugs and have a positive result, for a total of 70 who have a positive result. So we want to find the probability that they have a positive result or use drugs. So that is going to be the number who have a positive result, which is 70, plus the number who use drugs, which is 50, minus the number who do both, which is 45. So that gives us 120 minus 45, which is 75 people who have a positive result or use drugs. Moving on to the next problem. Here we're told that based on a journal article, the probability of randomly selecting someone who has sleepwalked is 0.292. So if the probability of people sleepwalking is 0.292. If a person is randomly selected, find the probability of getting someone who has not sleepwalked. Well, here, the probability that somebody has not sleepwalked is 1 minus the probability that they have sleepwalked. So that tells us that this is 1 minus 0.292, which is 0.718. So 718 out of 1,000 have not sleepwalked. Hit the wrong button there. Well, that's fine. That was not what we wanted. Sorry about that. Let's just do this. And we can go over there. That's fine. Okay, so the next problem asks us no, this is the wrong problem. Sorry, that's the same problem we just did. Okay, so recall from the results of our previous drug screening example using only the results from the subjects who use drugs. If 2 of these 50 subjects are randomly selected with replacement, find the probability that the first selected person had a positive test result and the second had a negative test result. This is with replacement. So a positive test result occurs 45 out of 50 times, and a negative test result occurs 5 out of 50 times. So the probability of first positive, second negative with replacement is just going to be 45 over 50 times 5 over 50, which is the same as 9 out of 10 times 1 out of 10, or 9 out of 100. 9/100ths probability. The second problem here asks us to repeat that by assuming the 2 subjects are selected without replacement. Okay, so without replacement, and never mind, this is fine. Without replacement, first positive, second negative, without replacement. Well, the first one is still 45 out of 50, But the second is 5 out of 49, just slightly different. That's still 9 out of 10 here, but then the second possibility, we can't reduce 5 out of 49. So this becomes 45 out of 490. That is only slightly different. We can actually simplify that a little bit. That gives us, let's see, divide the numerator and the denominator by 5. We get 9 out of 490 divided by 5 is 98. 9 out of 98. So the chances are slightly better of getting in the second situation than in the first. Moving on. In our next problem, we are asked to assume that 3 adults are randomly selected without replacement from the 247,436,830 adults in the United States, and assume that 10% of the adults in the US use drugs. We want to find the probability that the 3 selected adults all use drugs. Well, if we select 3 adults with a 10% chance of each, 3 is a lot less than 5% of 247 million, let alone 247,436,830. Because this is, because it's less, we can apply the 5% rule for cumbersome calculations and just assume that we're doing this without replacement, even though technically we are not. Doing it with replacement, even though technically we're doing it without replacement. So that's just 10% or 1/10 times 1/10 times 1/10 is 1/1000th. Is the probability that all 3 of these people use drugs. Moving on. Okay, the birthday problem. When 2 different people are selected randomly from those in the class, find the indicated probability by assuming that birthdays occur on the days of the week with equal frequencies. So first we're going to find the probability that the 2 people are born on the same day of the week, were born on the same day of the week, we should say, and then we'll find the probability that they're both born on Monday. So here, the probability that they're born on this same day of the week is just 1/7. Because we pick any person, say me, I was born on a Monday. And if I pick any of you, the chances that you were also born on a Monday are 1 in 7. But, you know, if we just pick 2 people at random, it really that can go for any day of the week. However, if we specifically check for the probability that the 2 people we pick are born on Monday, that's 1/7 times 1/7. We're picking 2 people and we want them both born on the same day. In the first situation, we only have to check whether, you know, based on what day the first person is born on, what day is the second person born on. Now we have to check that they're both born on Monday, and that's 1 in 49. So that is 7 times less likely than or 1/7 as likely, we should say, as both people being born on the same day of the week. I think we've got one more problem. Here is, okay, modern aircraft are now highly reliable, and one design contributing to that reliability is the use of redundancy, whereby critical components are duplicated, so if one fails, the other will work. For example, the Airbus 310 twin-engine airliner has 3 independent hydraulic systems. For this example, we assume that for a typical flight, the probability of a hydraulic system failure is 0.002. So if the Airbus 310 were to have one hydraulic system, what is the probability that the aircraft's flight control would work for a flight? Well, that's pretty easy to calculate because it's just going to be 1 minus the probability of failure, which is 1 minus 0.002 or 0.998. If there are 3 systems, that's what the other question asks. Given that the Airbus 310 actually has 3 independent hydraulic systems, what is the probability that on a typical flight control can be maintained with a working hydraulic system? Yeah. If there are 3 systems, well, we need 1 minus the probability that all fail. Now, these systems are independent, so the probability that each of them fails is the probability of failure cubed. So that's 1 minus 0.002 cubed, which is 1 minus 0.000000008, which is, of course, 0.999999992. That's it for this video. If you have any questions, please get in touch.